Okay, welcome America, welcome Taylor Swift. We were just talking about how you're not coming to DC on your tour, and we think that you should edit your tour so that you can come to DC. I'm sure the Verizon Center's open. I mean, I'm sure you could find a block and come to the Verizon Center. We would like that. Do they call it the Verizon Center now, or is it the Capital One Arena? I don't know. Capital One Arena. Okay. Anyway, welcome. We're going to be working on some very basic trig identities. Next class, we will be working on some more complicated ones. So these are normally very difficult every year for students, and they do take a lot of practice, and there's a lot of practice on this worksheet, which hopefully I will remember to attach. And we're going to do some of the problems today. And how these work is, the directions say verify. The word verify, we've got an equation here. It's a trig identity. It says cosecant times the cosine is equal to the cotangent. We need to verify that that's true, okay? All of these verifications that you're doing in pre-calculus are true, okay? You're not going to get one that's not, just because we are learning, and so that's how they are. When it says to verify the following trig identities, show all work and each step involved in the verification. What that means is you're going to work on one side until you get the other side. And you don't have to write down the other side. I'll show you how that works. You don't have to write down the other side every time for every single step. I usually write it at the very end and then do a check saying that they're equal. When they get more complicated, and I'll show you this next class, sometimes I look at the other side and try to see what I can do to the other side to make it look like the other side, but you can't work on both sides. You can't subtract something from both sides. It's not an equation like from Algebra 1 where you can, divide both sides by cosine, okay? You have to work on one side and show that I can simplify one side to make it equal to the other side. That's the first key. Second thing is, there we go, okay. I was going to say a second thing, but now I can't remember what it was. That's great. I guess we'll just start working. So you want to use any tools you can that you have. So reciprocal functions, Pythagorean identities, even in odd properties. You never know what you're going to use. And a lot of times when these problems get more complicated, you're going to start working and you're going to get nowhere, and it's going to be going nowhere near where you need to go. And you erase everything and you just start and try something else. Those probably won't happen today because these problems are pretty basic. And I know what the second thing was. You want to pick the side that's got more stuff going on so it's easier to simplify. If you've got a side like cotangent where it's already simplified, it's a little bit more difficult to expand cotangent into the left side. It's easier to simplify this more complicated left side to make it look like cotangent. And I don't know what's going to happen. I'm just going to try stuff and just see if it works. But the first thing I noticed is that cosecant, what's the reciprocal of cosecant? Okay, so I'm just going to rewrite the left side as 1 over the sine, and they're using x in this problem, times the cosine of x. All I did was rewrite cosecant as its reciprocal. Now, you can write cotangent if you'd like. I usually don't until I get to the very end. But now I can see that this cosine's in the numerator, so that's just over a 1. So that's equal to the cosine of x over the sine of x. So that's how I'll write that in the next step. And you want to do that right below it. And we're working down, not across. So the next step, and if you run out of room, I'll show you what to do. If you run out of room, you just use an arrow. So I'm going to rewrite this as the cosine of x over the sine of x. Now, isn't that equal to cotangent? So now the next step I can write cotangent. Well, that's equal to the cotangent of x. And that's usually when I put my cotangent of x on the other side because they're equal, and then I check it because it's been verified. How are we doing? Pretty basic question. We just used reciprocal functions. All right, the next one, if there's no questions, I'm going to go to number 2. All right, so, and if you run out of room, you can just draw like an arrow. Usually I go like this, and then, know, and then start working down somewhere else. But we should have room to do this next problem. I'll use a different color. So I guess I'll start on the left side, and I'm going to rewrite. I'm just going to leave cosine squared the way it is. What did I decide to do? Change cotangent. I'm going to rewrite cotangent as cosine over sine. Just try it. So, and there's no reason why you can't start on the right side. I just chose to start on the left. And I'm going to rewrite the denominator as the cosine of x over the sine of x. And put my equal sign. The equal sign is on the right because I'm working on the left. If I was working on the right, then my equal signs would be on the left side to show that I'm working on the right side. And I'll do that for another problem in a little bit. So now we can do keep, change, flip. So if I rewrite this as keep the numerator, change division to multiplication, and then flip this as sine over cosine, and I'll just rewrite that. I've got cosine squared of x times the sine of x over the cosine of x. One of those cosine, and I can't forget my equal sign, one of those cosines is going to cancel because this is like cosine squared over 1. So I've got cosine squared in the numerator now and one cosine in the denominator. So I can cancel one of those cosines. And then it's going to look like the right side. So if I cancel 1, and I'll just cancel the squared. And now I've run out of room. So I'm going to model what I'd like you to do if you run out of room. Just put an arrow. All right, I'm going to start working here now, down. So I'll simplify what I've done here. This is the cosine of x. You know what? I'm going to write sine of x first. Sine of x times the cosine of x. Well, that's exactly the same as the other side. So now I can write, and I've run out of room, equals, do my best. And that's been verified. How are we doing? Yeah.
How does the 2 get x'd out?
So what I did was, this is the cosine squared of x over 1 times the sine of x over cosine. So if I rewrote this just the way it is now, I would end up with, can I erase this stuff? I'm just kind of running out of room. I hope you guys have it written down. What did I have? I don't even remember what I had now. Cosine squared of x times, what was it? Sine over, it was sine over cosine. This is, I'm just going to put sine first. So these are being multiplied. So if you had like, I don't know, 3x squared over x, you can simplify that, divide an x out, and then that would be equal to just 3x. Because x squared over x is just equal to x. Because when you divide, when you have the same base, you subtract the exponents. That's from like algebra 1. So one of the cosines we can cancel out, but there's still one left because this is a cosine squared. Okay, so I think I'm done with my video. It's almost 10 minutes.